Alright, what's going on? This video we're going to look at the fundamental identity and reference angles. So as far as I'm concerned in Trig, this is probably one of the most important sections that you need to grasp, and that's reference angles. If you can understand reference angles, then Trig's going to be so much easier for you. So let's go ahead and get started. So first, let's look at the quadrants here. We got the first, second, third, and fourth quadrant. Now, what this does is this tells us, I'm going to tell you what trig functions are positive in which quadrants. So I'm sure all of you have heard this before. All students take calculus. Okay, so here all of the trig functions are positive in the first quadrant. In the second quadrant, only the sine. In the third quadrant, tangent. In the fourth quadrant, cosine. Okay, now if sine is positive, then that also means cosecant's positive in the second quadrant. If tangent is positive, that means cotangent is also positive, because remember, they're reciprocals of each other. And then if cosine is positive, that means secant is positive. So all of them are positive in the first quadrant: sine, tangent, cosine. And what goes with sine? Cosecant. Tangent, cotangent, cosine, secant. All right, so all positive here. Sine and cosecant's positive in the second quadrant, tangent, cotangent positive in the third quadrant, and cosine and secant are positive in the fourth quadrant. All right, so that's important to know. All right, and if you're taking notes while you're watching this, write that down. Write this down. Write it all down, because it's all important. All right, so the fundamental identity of trigonometry: if alpha is any angle or real number, then, well, look at that. I wrote that wrong, didn't I? Sine squared alpha plus cosine squared alpha is equal to 1. Okay? I left the squares off. Why, I don't know when I was writing these up, but that's sine squared plus cosine squared equals 1. That's an identity. You need to know that identity. You will use that identity a lot in Trig. And as the videos go, these videos, basically, I'm taking a Trig book and I'm doing each section in a video. Okay, so we'll get to some more Trig identities later on in some other videos. All right, so what can we do with these Trig identities? Well, it's a lot. We can do a lot with them. But let's look at one thing we can do with them. We have an example here. It says find cosine alpha if sine alpha is equal to 3/5 and alpha is an angle in the second quadrant. All right, so if you've watched past videos, you saw where we drew this, and we drew something like this, and we labeled this and this and this, and we found all the trig functions like that. Well, you can do that with this, but another way that you can do this is we can use this identity here. And to me, using this identity, I think it's a little quicker. I think it's a little quicker than the other way. So if we look at this, they give us sine alpha. All right, so sine alpha is 3/5. So if we replace sine alpha with 3/5, now remember, sine alpha is 3/5, but this is sine squared. So the 3/5 is squared, plus cosine squared alpha is equal to 1. Okay, so this is going to give me 9/25 plus cosine squared alpha equals 1. And then what are we doing here? We're subtracting 9/25 to both sides. And so we get cosine squared alpha is equal to 16/25. Now, how did you get that? How did you get 16/25? I did 1 minus 9/25. You're in trig now. You should know how to add and subtract fractions, okay? I'll give you a hint. Get a common denominator. So now, what is cosine alpha? Well, cosine alpha is equal to what? 4/5, right? Now, let's stop here for just a second. Is that correct, what I've written down? Think about it. No, that's not correct, is it? So let's jump back to algebra for just a second. If you have x squared equals 9, then x is equal to what? Plus or minus 3. Remember that square root property? So we're doing the same thing here. We're square rooting both sides. So I'm using that square root property. So cosine alpha is equal to 4/5, or cosine alpha is equal to negative 4/5. Don't forget that. That's very important. All right. Now which one is it? How do we know which answer it is? Well, let's look. They're telling us that alpha is in the second quadrant. So remember back up here, I'm in the second quadrant. Sine and cosecant are positive in the second quadrant. All the other trig functions are negative in the second quadrant. So I have cosine alpha. So cosine alpha in the second quadrant is negative. So that means this one is not a solution. My solution is this one. All right. So hopefully that made sense. So that's one way that you can use that identity. So if they give you sine, you can find cosine real quick, or if they give you cosine, you can find sine real quick. Okay, it's pretty easy. I think it's easier to do this than to draw the triangle and all that stuff. But if you like drawing that triangle and you want to do that, there's nothing wrong with it. Okay, you can do that on every problem, unless your teacher has a problem on the test that says use the identity to find it. Okay, if your teacher doesn't tell you how to find it, you can do it like this, or you can draw the triangle. All right, reference angles. So this is blank. I left a bunch of space here. This is blank, reference angles, because I want to draw this and explain it as I'm drawing it. All right, so for the reference angles. Now remember, a reference angle is an angle between 0 and 90 degrees. Okay, your reference angle is always a measure that would be in the first quadrant. It's between 0 and 90 degrees. So let's draw these reference angles. So we're going to look at the reference angle in every quadrant. So if I have an angle in the first quadrant, and we call this angle theta, that's a theta. Doesn't look very good, but that's what it is. Theta. All right. Well, this is also my reference angle. Now this little mark here, that represents the reference angle. That's how we denote a reference angle. Okay, so you might be watching this video and thinking, well, that's not how my teacher did it. My teacher didn't use that mark. They may not have. Okay, the book that I'm using, this is how they represent the reference angle. Okay, other ways that I've seen the reference angle, well, the way that I did it. Another way, I've seen it with a line over it. That means reference angle. And I've also seen it where it has a subscript R. Okay, there may be some other ones that I haven't seen, but you know, different books will use different symbols to represent reference angle. But for this video, we're going to use this notation here to represent a reference angle. So if you have an angle that's in the first quadrant, that's your reference angle. Okay? All right. Now, and look, I'm telling you, write all this down, take notes. This is so important that you get this for trig. All right. So now let's suppose we have an angle in the second quadrant. Okay, we got an angle in the second quadrant. This is my reference angle. Right here. There's my reference angle. Now, let's look at this. Okay? So we've got our angle in the second quadrant. Now, a lot of books, what they'll do is they'll put down the formulas and stuff of how you calculate the reference angle and all that stuff. Let's go through it. Let's work it out. So you're not memorizing anything. I want you to understand how to get that reference angle. So let's think about this. So remember, this is 0 degrees over here. Then we've got 90 degrees up here. We've got 180 here and 270 here. And then we go back to 360. So if you look at this, if I rotate to 180 degrees, okay, I rotate to 180 degrees, and then I subtract off theta. Do you see that? Look. Let me draw it down here. So if I rotate to 180 degrees, and then and from here to here is theta. If I take that off, you see how I'm left with just my reference angle? So to calculate my reference angle, I would do 180 degrees minus theta. And that's how you would calculate that reference angle. Okay? Now, this is in degrees. What would it look like? What would it look like if I was in radians? Well, my reference angle in radians would be what? Pi minus theta. Pi is pi radians, that's 180 degrees. One's just in radians, the other one's in degrees. Okay? All right. Now, let's look at the third quadrant. So here's theta. There's theta. Now, which one is my reference angle? It's this one. All right, there's my reference angle. Okay. Now, how do I calculate that reference angle? Well, look at this. Let's draw this. So let's see, we're going to draw all the way to here. Okay, so remember, this whole thing here, all the way around, that's theta. You see that? And this piece here is theta prime, just this little piece. So look, if I take all of theta, okay, if I take all of theta, and then I subtract off the 180 degrees, I'm left with my reference angle. So in this case, theta prime would be theta minus 180 degrees. All right. And then once again, we could put this in terms of radians. That would be theta minus pi. Now, let's do the same thing. Let's go to the fourth quadrant. All right, so fourth quadrant, there's theta. All right, so what's theta prime? Well, this would be theta prime, right? There's my reference angle. So once again, let's draw that again and see how this works out. So look at this. If we go all the way around, so this is what? I went all the way around. That's 360 degrees. And then all the way around to here is theta. But if I subtract that off, that leaves me with my reference angle. So what did I do? I said theta prime, I went all the way around 360 degrees minus, and then I subtracted off theta. And if I put that in radians, then theta prime is 2 pi minus theta. So that's your reference angles. That's how you calculate your reference angles. Okay? Now, I want you to pay real close attention to this, because sometimes what we get students doing is they'll label this as the reference angle, or they'll label this as the reference angle, or they'll label this as the reference angle. Okay? Remember, your reference angle is always measured off the x-axis. Okay? One thing you can do is, when you're looking at reference angles, let's draw this. You see that? Think of a bow tie. Okay? Your reference angles are always measured off the x-axis. Think of a bow tie. All right? You never measure your reference angle off the y-axis, only the x-axis. That's important. All right, so let's look at this example. And like I said, I'm telling you, this is so important that you get this. Okay? Reference angles are very important. And what you can do is, if you want to watch some more of a video, I have a video on my YouTube channel. If you search my channel, just type in reference angles, and there's a video on just reference angles. All right. Oh, actually, what would be good, you could pull that video up and work those problems in that video, and then play the video and see if you get them right. All right. So for each given angle theta, sketch the reference angle theta prime and give the measure of theta prime in both radians and degrees. All right, so what we're going to do, we're going to, the ones that are in degrees, we're going to give that answer in degrees. The ones in radians, we'll give that answer in radians. All right, so let's go ahead and sketch this. So we've got 120 degrees. That's in the second quadrant. Okay, so there's 120. And where's my reference angle? It's right here. All right, so all they're wanting right now, they're just wanting to know what's the reference angle. So the reference angle, well, what is that? So I got to go all the way around to 180. And then I'm going to subtract off what? 120. And so that's going to give me 60 degrees. And there's your reference angle. And actually, this book, when it says give your reference angle in both radians and degrees, I mean, you've got 60 degrees. So they're wanting you to also write pi over 3. I guess just to get you familiar with, or if you to get familiar with degrees and radians. If you remember in some of the past videos that I've done, if you've watched those, remember I told you it's important to know just right off the top of your head, 30 degrees, pi over 6 radians, 60 degrees, pi over 3 radians, 45 degrees, pi over 4 radians. It's really important that you associate those real quick. All right, now let's look at this, 7 pi over 6. All right, so where is 7 pi over 6? Well, 7 pi over 6 is right here. It's in the third quadrant. All right. Now, you might be wondering, well, how do you know that it's in the third quadrant? How do you do that? Well, let me go over that. I'm gonna come back up here. Let's erase this. And I'm going to show you kind of a quick way that you can do it, because it's usually a little tougher to determine where radians are. Okay. So we've got 7 pi over 6. So if you look at this pi over 2, do you agree that's the same thing as 1/2 pi, right? And 1/2 is what? That's 0.5 pi. This is what? 1 pi. 3 pi over 2, or 3 halves pi, isn't that the same thing as 1.5 pi? You see that? So what do we have? We have 7 pi over 6. What's 7 divided by 6? 7 divided by 6 is 1.167 pi. Okay? So look at this. You see how this is 1, this is 1.5, 1.16, that falls in between there, doesn't it? And that's a quick way you can do it, okay? The other way, you could actually, if you needed to, you could take that and convert it to degrees, okay? But I'm telling you, it's good for you to be able to work with these things in radians, though, all right? When you get into higher math classes like calculus and stuff like that, you know, if you have to take those, that's all you're going to really be working with is radian measure. All right, so we're in the third quadrant, and this is our reference angle. Okay, so how do we calculate it? Well, that's going to be theta prime is equal to, so how do we get that? Well, we're going to go all the way around to 7 pi over 6. And then we'll do what? We'll subtract off this 180 degrees. So we would what? Subtract off pi. And that would give us what? Pi over 6. And there's your reference angle. Now, pi over 6, what is that in degrees? That's 30 degrees, right? All right. So once again, 7 pi over 6 minus pi. Once again, that's knowing how to add and subtract fractions. Okay, you're supposed to know how to do that when you're in trig. All right, so now we've got 690 degrees. All right, so 690, well, typically when we're working with angles, we want our angle measures to be between 0 and 360, don't we? So we can use the fact of what? What do we know? How can we get it back between 0 and 360? Coterminal angles, remember that? So if I do 690 minus 360, because remember, coterminal angles, say 690 minus 360 is 330. Remember, coterminal angles have the same terminal side. So now let's draw this out. So 330 is in the fourth quadrant. This is 330 degrees, and here's my reference angle. Whoop, I'm sorry, I don't know why I wrote that. Getting ahead of myself, aren't I? All right. So now we got to figure out what's the reference angle. So the reference angle, that is what? That's going to be go all the way around to 360, and I'm going to subtract off the 330. And so that is 30 degrees. And then once again, what would 30 degrees be in radians? Pi over 6. Okay. See, this is really pretty easy, and hang with me in the video. Don't stop watching, because we're going to do some more. We're going to find the sine and cosine of these angles here. We're going to find the sine and cosine. But we're going to use reference angles to do it. That's important to know how to do that. All right, what about this one? Negative 7 pi over 4. So how are we going to go about doing that? Well, once again, let's get our angle measure between 0 and 360. Well, we don't need to say 360, do we? Because we're in radians, so we want to get it between what? 0 and 2 pi. Okay, so I've got negative 7 pi over 4, and I'm going to add 2 pi. And so what is that? Pi over 4. So let's draw that. Well, pi over 4, that's in the first quadrant, isn't it? There's my angle. Well, guess what? That's also my reference angle. Remember, if theta is in the first quadrant, then that's also your reference angle. Theta is also your reference angle. That's from up here, this one right here. If theta's in the first, that's also your reference angle. Now, what's pi over 4 in degrees? That's right, that's 45 degrees. All right. I was looking at this. I think I'm going to have to change that problem when we get to it. All right, so let's look at this. Find the sine and cosine. Find the sine and cosine of 150 degrees. All right, so this is important right here. Whenever you're calculating sine and cosine of angles and stuff, and actually I think these directions, it should say find the exact values of sine and cosine, where you can't use a calculator. So we don't know the sine and cosine of 150. We don't really know the sine and cosine and tangent of anything larger than 90. Except for what? Except for we know the sine, cosine, and tangent of 90, 180, 270, and 360. We know those. But not stuff like 135, 210, 330, 315, 300. That's just something you don't need to memorize. You don't need to memorize those. If you've watched these other videos, then you know I've told you, especially in that last video. I wrote every one of them down in the last video. Click on the video before this one, and it's kind of right there at the first. I write all that down. But you've got to know the sine, cosine, and tangent of 30, 45, and 60. 30, 45, and 60. And that's what we're going to use here to calculate these things. We're going to use reference angles. So we've got 150 degrees. So what I've got to do is I've got to get the reference angle. So here's 150 degrees. There's 150. Here's my reference angle. And so I know my reference angle is 180 minus 150, which equals 30 degrees. Okay? All right. So now I can go ahead and find the sine of 150, and I can find the cosine of 150. All right, so first, let's find the cosine of 150 first, and then we'll do the sine. So the cosine of 150, well, the reference angle is 30 degrees, right? That's the reference angle. So what's the cosine of 30 degrees? Well, that's what? Square root of 3 over 2. Okay, if you're watching this video and you're saying, huh, how did you get that? You've got to memorize these. Okay, sine, cosine, and tangent of 30, 45, and 60. If you've been watching these videos, you're probably sick of hearing me say it, but you've got to memorize them. Okay, so what that reference angle's doing, that's getting us this value here, but we're not done yet. So once we get that value, we know the cosine of 30 is square root of 3 over 2. Okay, we know it's square root of 3 over 2. Now, what quadrant are we in? We're in the second quadrant, right? 150 degrees, that's in the second quadrant. Cosine, is it positive or negative in the second quadrant? It's negative. So that's negative square root of 3 over 2. There's your answer. So what we're doing is we're using the reference angle to get this value, whether it's 1/2 square root of 3 over 2, whatever that is. We're using that reference angle to get this value. Then we've got to say, okay, what quadrant is it in? Is it positive or negative? And that's how you do these. All right, so let's do sine 150. Reference angle is 30. What's the sine of 30? That's 1/2, right? Okay, which quadrant are we in? We're in the second quadrant. Is sine positive or negative in the second quadrant? It's positive. That's your answer. Okay. All right, let's do 4 pi over 3. All right, so let's draw this. Now 4 pi over 3, that's in the third quadrant. That's 4 pi over 3. Here's my reference angle. So my reference angle is, let's come down here. Reference angle is going to be what? 4 pi over 3 minus pi. So that's going to be what? Pi over 3. All right, so this is pi over 3. So now I need the sine of 4 pi over 3, and I can calculate the cosine of 4 pi over 3. All right, so stay with me now. So the sine of 4 pi over 3. Well, my reference angle is pi over 3. So what's the sine of pi over 3? All right, so we're saying, we're looking at that sine of pi over 3, and in our heads, we're also thinking sine of 60, right? Because we know pi over 3 is 60 degrees. Okay, so sometimes it's usually easier to remember these things when they're in degrees, but you've got to be able to work with radians also. Okay, you've got to be able to work with radians. All right, so we've got sine of 4 pi over 3. So the sine of pi over 3, or sine of 60, is square root of 3 over 2. All right. What quadrant am I in? Third. So that's negative. See that? It's that easy. Do the next one. Cosine of 4 pi over 3. Reference angle is pi over 3. What's the cosine of pi over 3? Or what's the cosine of 60? That's 1/2. Okay? So we got the value. Now, is it positive or negative? Well, what quadrant am I in? I'm in the third quadrant. Cosine is negative in the third quadrant. There's your answer. Okay? Now, I know some of you, I know a lot of you in, high school and like that, your teacher will tell you, remember the unit circle. Okay? Some teachers are big on that unit circle. That's, I don't teach it. I don't show my students the unit circle. Okay? The unit circle works on when you're dealing with 30, 45, 60 degrees reference angles. It works on that. But that's it. Okay? It doesn't work. It's not going to work on things later on in the trig course when you're solving trigonometric equations and you're finding all those values and you don't have a 30, 45, or 60 degree reference angle. You're going to have to use reference angles. Reference angles works on everything. That unit circle don't. So if you're in high school, go tell your teacher to quit teaching you that unit circle and concentrate on reference angles. Okay? And if you tell them that, you can comment on this video to tell me how mad they got. All right. But anyway, I'm going to change that 720 because that's not going to work out good. Let's change it to 690. Okay. All right. So what's the sine or cosine of 690 degrees? Okay. Well, we don't know. Well, let's find the reference angle. So first thing I'm going to have to do is I'm going to have to take this 690 minus 360, and that equals 330. Yes, I know that's just like one of the ones we did a while ago. We found the reference angle for 690. Well, let's do it again. All right. So we've got 690 reference angle. The coterminal angle. And I don't know if I said reference angle up here. I meant coterminal if I said reference. My bad. But let's go ahead and do this. 330. Here's my reference angle. So my reference angle is what? 360 minus 330 is equal to 30 degrees. That's my reference angle, 30 degrees. So now let's find the sine of 690 and the cosine. And the cosine of 690. All right. So sine 690, well, we don't know, but we've got our reference angle of 30. So what's the sine of 30? That is 1/2. Okay, that gets us the value. Now I've got to go back. Which quadrant am I in? I'm in the fourth quadrant. What is sine in the fourth quadrant? It's negative. There's your answer. Now let's do cosine. What's the cosine of 30 degrees? Square root of 3 over 2, right? What quadrant am I in? Fourth. Is cosine positive or negative in the fourth quadrant? That is correct. It is positive. There's your answer. Okay. All right, let's do this one. Negative 7 pi over 4. So first, let's get it back between 0 and 360. So negative 7 pi over 4 plus 2 pi, that is equal to pi over 4. All right, well, that's going to be easy, isn't it? Pi over 4 is in the first quadrant. Okay, there's pi over 4. And so now I can do the sine of negative 7 pi over 4. And I can do the cosine of negative 7 pi over 4. All right. So the sine and cosine of negative 7 pi over 4 don't have a clue, do we? That's why we found the reference angle, pi over 4. What's the sine of pi over 4? Or another way we can look at it is how? Sine of 45, right? Pi over 4, 45 degrees. That's what? Square root of 2 over 2. Which quadrant am I in? First quadrant. Well, in the first quadrant, we know they're all positive. Same thing here, cosine, pi over 4, square root of 2 over 2. We're in the first quadrant. Cosine is positive. Don't forget, all students take calculus. All right, well, look at this. This is the last problem here. So we've got an application here, an application problem. So let's see what this says. It says the tide in the Bay of Fundy rises and falls every 13 hours as shown in the figure. The depth of the water at a certain point in the bay is modeled by the function. So this right here is the depth of the water. It's modeled by this function here. D is equal to 8 sine of 2 pi over 13 t plus 9. Okay. Where t is time in hours and d is depth in meters. Find the depth at t equals 13 over 4. That's high tide. And t equals 39 over 4. That's low tide. So we want to find the depth there. All right, so let's do that. So, and this right here, I included this graphic. That's what it looks like. When you graph this function up here, that looks like that. Now, you might be wondering, well, how do you graph these things? How do you graph these? Well, that's in the next video. We start learning how to graph. Actually, now that I'm looking at it, the next section is the unit circle and graphing. I'll probably mention the unit circle, but I'll talk bad about it, and then we'll talk a little bit about graphing. That video may not be long, but anyway, yeah, the next set of videos is going to be graphing, where we're going to do sine and cosine will be one video, and then we'll look at secant and cosecant, and then in another video look at tangent and cotangent. So if you're interested in graphing. All right, so let's go ahead and do this. So we get d equals 8 times the sine of 2 pi over 13 times, let's write it like this, times, let's do the 13 over 4 first. So times 13 over, that's a 4 there. And then we got what, plus 9. So all I did is the 13 over 4, I put that in the place of t. That's all I did. And so this is going to be 8 times the sine of, what is that? Look at that, 13s go out, and 2 over 4, that reduces to pi over 2 plus 9. Well, look at that. That's one of the ones you've got to remember. Sine of pi over 2, that's what? Sine of 90 degrees, right? See that? Sine of 90 degrees. So this is going to be 8 times, and then the sine of 90 is 1, and then that is plus 9, and so that gives us 17 meters. That's the depth of the water at high tide. And then low tide, well, d is equal to 8 times the sine of 2 pi over 13 times, and then we're going to put in the 39 over 4, 39 over 4 plus 9, and that is, well, look at that, 13 and 39, I'm left with a 3 and a 1, left with 2 and a 1. So this is going to be 8 times the sine of, all right, so now we got 3 pi over 2 plus 9. That's a 3 in front of the pi. It doesn't look like it. I'll rewrite it. I'll get comments on how bad my handwriting is. All right, plus 9. So this is going to be 8. Now, what's the sine of 3 pi over 2? What's 3 over pi? What's 3 pi over 2? Real quick in degrees. That's right, 270. Sine of 270 is -1. Remember, that's one of the ones I told you have to memorize. Plus 9. So that's -8 plus 9 is 1. So that's 1 meter. So the low tide is 1 meter. And there you go. So, you know, so far what we've been doing, all the stuff that we've been calculating, sine, cosine, tangent, whatever it is, all the stuff that we've been calculating have been nice angles. We've been able to use 30, 45, and 60 degrees. Okay? And that's why I'm telling you, memorize sine, cosine, and tangent of 0, 30, 45, 60, 90, 180, 270, and 360. Memorize those. Unit circle, forget about that thing. Okay? It's nice when you have that, but you've got to know how to do reference angles. If you can't do reference angles, you're going to fail trig. Okay? You won't do good in it at all. You've got to understand how to do reference angles. All right. So that's the end of this video. I hope it helped. And I'm telling you, reference angles are really, really, really important. Okay? So check out my other videos. Give me a like, share, and subscribe. And I'll see you later.